Alright, so I'll get started. We are told to do questions 3 to 10 and solve them, I guess, for everything. So I'm going to bring in a piece of paper over here. Stupid extra questions. And 3. Oh, gosh, I really don't want to do this. We have an Oz triangle, so let's just write everything we know. 79 degrees, 33 degrees. A is 7. I already drew it, so I'm not going to draw it again. Let's just use the law of sine. So I'm going to calculate this B and also angle C because that's pretty easy. 180 minus that is 68 degrees. I'm just going to write this out because my teacher probably wants it. Sine 79 over 7 equals sine 33 over B. So B would equal 7 sine 33 over sine 79. Put that into the calculator. B equals 3.884. I could have sworn I got the same thing not too long ago. Are we repeating questions here? 3.884. 3. Aha! Wait a second. What is this? Have we been doing repeat problems? Oh my goodness! Would you look at that? So, it turns out, I actually just did this is why I recognize the number so hard. Question 51. B equals sine 33 over sine 79. I'm really mad. Why would you waste my time like that? That's so rude. So disrespectful. Hopefully there are more repeats so I don't have to do as much work. But I'm just going to copy down because you already made us do this. There was another one at the end of this parallelogram that we had to solve was also in one of the previous packets we got. So please stop giving us the same question over and over again. C equals 6.612. 4. Next question, what do we got? 5, 8, and 100. These are the same questions! What is this, 65, 19, and 22? Oh, okay, so they are different. Already did it. 5, already done. 6, already done. 65, 19, and 22. Let's write these out. To use the law of cosines here to find C. Just from experience, I know how this rearranges. Although this is very similar to the original equations, just move the square root over, because this used to be C squared. 19 squared plus 22 squared minus 2 times 19 times 22 cosine 65. And I write it this way only because it's just easy. That's exactly how I type it into my calculator. I should move this over to this side so this is the center of attention because that's what it deserves to be. Cosine 65, which gives us C equals 22.174. I'm going to calculate B also with the law of cosines because there's a chance that you get the ambiguous case if you try to use law of sines after you use law of cosines here. B is going to equal A squared plus C squared minus B squared over 2AC. That's just how the law of cosines equation gets rearranged. Oh, oops. I always forget this one and I always get a really small answer. And I wonder why for a second, and I remember that I forgot arc cosine at the beginning. So we're going to start with arc cosine fraction. A squared is 19 squared plus the previous answer we got squared, which is going to be C squared minus B squared, which is 22 squared over 2 times 19 times and 64.052 because it's rounded up, and that makes sense because if these two sides are so similar to each other then the angles should also be pretty similar. We can add 65 to this and 180 minus that should give us angle A, which is 50.948. Let's see if I've done 8. 8 is 1, 5, and 8. No triangles, so I don't have to solve it. 9 is 57, 11, and 10. Do I have 57, 11, 10? Oh, it's an ass case. Oh, there's 2. Oh, no. A, B, C, A, B, C. 1, 1, 1, 2, 2, 2. 2 equals angle C 57, B is 11, C is 10. Now that we have all of that filled in, we can do the sketch, which I've already done over here, but just to run through my general strategy for ask cases is start with the angle that we're given, which in this case is 57 or C, so I'm going to write it as a point, draw a dotted line this way, approximate 57, it's close to 60. This point is going to be what we don't know, so this is A. We don't know side A, so that means we don't know this side. This is just from experience. I can't really say it's experience. I've only been doing this for like a week or so, but the patterns I've picked up, I guess, is a better way to say it. The side that doesn't correspond to the angle is going to be this side right here, 11. 11 is greater than 10, which means I think I also figured out that 10 is greater than the height of this right triangle that would be made if I brought down an altitude right there. What that means is I can just go ahead and start calculating the rest, because it'll make two triangles. One of them is going to be like this and the other is going to be like this. This is 10. This is 10. But it'll give us this angle first, which is B1. This is B2 right here. Sine 57, using law of sines here, sine 57 over 10, right, that's our C, equals sine B1 over 11. B equals arc sine of 11 sine 57 over 10. Put that in the calculator real quick. That gives us 67.299. Since 11 and 10 are close to each other, the angles should also be pretty close to each other. Oh, I guess we're going 300 because there's too many 9s here. We're going to store this as x because that just makes it easier. I don't have to go back into the calculator to find these again. We can find A by adding 57 to that. 57, 180 minus that is 55.7. I should probably use all of the zeros here. We can use that to calculate A. Sine, I'm just going to write it as A because I don't feel like writing 55.7. A1 equals the same ratio that we had here, which is sine 57 over 10, and cross multiply gives us A, cross multiply and rearrange, 10 sine A over sine 57 gives us 9.850, which makes sense again because 60 is decently close to a equilateral triangle, which means that these should be pretty close to each other, and 55 being the smallest angle means the corresponding side should also be the smallest side. Next we have A2 and B2 to calculate. We can calculate B2 by going 180 minus B1, 112.700. Add this to the 57 we have already, so plus 57, 180 minus that should give us something pretty small. Yep, 10.300 degrees. Again, using law of sines, we're going to go sine 57 over 10 equals sine A over A, and so it's A2 equals 10 sine A over sine 57, and that gives us 2.132. And so that's our entire triangle solved, and we have one more question left, which is an SSS case, meaning we have to use law of cosines. Number 10. Did I do this? We have 5, 7, 6. Do I have a triangle here that's 5, 7, 6? I do! Okay, so I can just... already done. I should probably specify which one this is. What we learned today is that math teachers can sometimes assign too much homework and not realize that it's kind of useless because we already did it. And we have this packet, mixed practice, law of sines, and law of cosines. Then we have more mixed practice, and then we have some more homework, and then we have this packet, P set 4, and then we have these stupid extra questions, and that means that I am finished with math homework for the next week, and I'm really, really happy about that. Yeah, it's going to be nice. Finally. Gosh. Oh, I still have physics.